Hi everyone, welcome to GemChem. Now today's topic of discussion is IUPAC nomenclature for symmetric binuclear complexes with bridging ligands or with metal-metal bond. Now before starting, already 6 videos are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present about this video. And in the previous video, we had already seen how to name the normal coordination compounds, and there was checkpoint given, and these were the 3 complexes for which you had to write the names. So the first one will be your tris eta 3 propenyl chromium 3. For the second one, the answer would be your penta aqua nitrito kappa O cobalt 3 sulfate, and the last one would be pentaamine thiocyanato kappa S iron 3 chloride. Now we are going to see what are the rules regarding naming of the bridging ligands. So the name of the bridging ligand should be written as the first by using the prefix, and the prefix used in this case is our mu. So we are going to write mu, and if suppose you have a bridging ligand as any kind of halo, that is suppose chlorido, so you can write mu chlorido and continue writing with the rest of the name portion, right? Now the second rule is that the name of the bridging ligand should be separated from the rest of the name by using hyphen. And the third important rule is that the bridging index of the bridging ligand is given if it bridges to 3 or more metal centers. That is, if you are saying that it is bridging with 3 metal center, you have to write it as mu 3. So this is important. Now we are going to shift and try to do these examples. This will be hydroxido. So we start writing. You have to first compress the structure. So from here only you can see it is mu OH, and the rest of the structure is Cr H2O whole 5, and it is twice in number, right? And outside bracket we have Br5. So the name will be written as your mu hydroxido, and we have to give a hyphen after writing mu, then give a dash and then write bis, since there is twice of the chromium part, penta aqua chromium, and here the charge of the chromium is 5 plus, so you are going to write 5 plus, and in the same line by giving a space you are going to write bromide. So this is the name, right? Now we go for the next one. So in the next one you can see that it has a oxido bridging ligand as well as a imido bridging ligand. So in this case we are going to compress the structure mu NH. We have mu O, and we have Fe phenanthrolene, which is twice in number, and the whole is twice in number, and outside the bracket we have sulfate. So for this the name will be mu imido, then again a hyphen mu oxido, then again a hyphen, after that bis, because there is twice, again give a bracket, and there is 2 times phenanthrolene, so we are going to write bis phenanthrolene, then close the bracket of phenanthrolene, then continue writing iron, and you have to write the charge of the iron as 2 plus, followed by your anionic part, that is sulfate, SULPHATE. So the full name comes to be as mu imido, mu oxido, bis phenanthrolene, iron 2 plus sulfate. Now we are going to shift to our next example, that is this one. So here only you can see that there is 3 ligands, right, which is acting as a bridging ligand. So we are going to write it as, see here, tri, then give a dash mu, then write down as carbonyl, because this is a carbonyl group in the bridging ligand, give a dash bis for the two parts present this side and this side. So bis, again open the bracket, write down tri carbonyl. Since I have no space, I am going to the next line, but you are going to write in the same space tricarbonyl, and then you will write iron and close the bracket, write the charge of, here the iron is in 0 oxidation state. Now we are going to shift to our next example, where you can see here that we have O2 and NH2. Here 2 is missing, so please write down here it is 2, NH2. Now remember, very important this part, that O2 means it can be molecular oxygen or it can stay as O2 minus, which stands for superoxide, or it can stay as O2 2 minus. So it will be peroxide, right? So if we consider this one, then here let us take the valency or the power of cobalt oxidation state to be X. So there is 2 times cobalt, so it will be 2x. Now we are considering it by doing with the help of superoxide. So O2 is considered to have -1 charge and your NH2 will have -1 charge and your total thing has 2 plus charge. So here we write 2. As a result of which X comes to be as 2. But when we consider it as 2x and O2 is considered as peroxide, then it will be -2, and for amine it will be -1 and it will be +2. As a result of which your 2x will come to be equal to 5 and x will come to be 5/2, which is a fractional number. So here in this case oxygen is in the form of superoxide. So finally we are going to write the name. So first we are going to write mu amino, because A comes first. Then we are going to give a hyphen and write mu superoxido. Then we are going to give a hyphen and write bis. Again open the bracket. For this too you are going to write bis. Open a bracket and write ethylene diamine. Followed by closing of bracket cobalt, then close the bracket, and you know the cobalt is placed in 2 plus. So write down 2 plus, give a space and write down bromide. So the whole name comes to be as your mu amino, mu superoxido, bis ethylene diamine, cobalt 2 plus, bromide. Now we are going to shift to an important compound which is known as basic beryllium acetate, and its formula is like this. That is, we have Be 4 oxygen and CH3 COO whole 6. This is basic beryllium acetate, and in this case you have to write down its IUPAC name. For that you have to understand the oxidation state of beryllium. So here it is 4x, here O stands for -2, and here there is acetate, so -6 in number, which is equals to 0. So you have x equals to 2. The structure looks like this. You have oxide in a tetrahedral shape. You have beryllium placed in each hands of this one, and each of this beryllium is actually connected by this CH3COO. Each is like this. Here you have O, here you have this one, O and this. So here it looks like this. Now each of them start connecting. You can see that this is the total structure. So from here you can understand that there will be 6 acetate bridging ligand and there will be 1 oxide which is connecting with the 4 beryllium. So we can write it as, start writing hexa dash mu. Since there is 6 in number acetato, one connection is by O, another connection is by another O. So we write O dash, give a dash, write mu. Since there is 4 in number with the oxido, so write down 4 in the subscript, write down oxido here, followed by a hyphen, then write down tetra. You have to write in the same line beryllium, and you have already seen what is the oxidation state of beryllium, so write down 2. So this is one of the important nomenclatures which is coming from this portion, right? Now I will give you some few more examples which you are going to solve on your own. So try it, these two. This is neutral actually, and the previous next one is this one. So for these two you are going to write down the name. So this is your checkpoint for regards to the nomenclature. Now see here, this is the checkpoint with regards to the coordination chemistry up to which we have already done. So take a screenshot, try to do this. When you are being able to do this, let me know in the comment section, and after that I would provide you with the solution video for this one. So this is the first page of your checkpoint questions and this is the second page of your checkpoint question. So this much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.